Okay, what we're going to do now is start in section 1.4, part A. All right, I know I'll have to interpret this for you. I know that you can't read this. So in 1.3, we talked about adding and subtracting, positive and negative whole numbers. We talked about adding and subtracting with fractions. We talked about multiplying and dividing with positive and negative whole numbers. We talked about multiplying with fractions, and we talked about exponents. Okay, so now section 1.4, in comes the algebra. Now, let me cover this up for just a second. Just a minute to do this. You'll see why I'm doing this in just 1 second. Let's suppose I wanted to add 3 plus 2, which equals 5. Now, let's suppose I put the word apples behind the 3 there. So if I said 3 apples plus 2, what would have to be behind that 2 in order for me to add these two together? Could it be 2 oranges? No. Could it be 2 grapes? No. In order for me to add these two together, it has to be apples. So 2 apples plus 3 apples is 5 apples. Now, if these were different right here, if this said apples and this didn't say apples, you can't add them together. Well, now let's translate that over into algebra. In algebra, the number that is in front of a term, that number right there and that number right there, the mathematical name is called the coefficient. And so the coefficients can be different, but what's behind these numbers has to be the same. So if I had 3 apples plus 2 oranges, you wouldn't say 5 apple oranges. Hopefully you wouldn't. You'd say you can't add them. Well, it's the same way in math. If I put a letter behind this, whatever letter I put behind this 3 has to be behind this 2 in order for me to add them or subtract them. So, if I had 3 apples plus 2, can't add those. You say, well, yeah, it's 5. No, I didn't say 2 apples. I just said 2. So these two terms cannot be added together. These are what we call unlike terms. 2 terms are like terms if everything behind their coefficients are the same. So, let's change it now to letters. So if I had 3x plus 2, can I add them together? No, because what's behind this coefficient is not what's behind this coefficient. So I can't add these for the same reason I can't add these. However, if I put 3x plus 2x, now I can add them together. 3x plus 2x is 5x. Now, one thing sometimes students want to do is they'll say, Mr. Rayner, why is that not 5x squared? Well, let's go back to the 3 apples and 2 apples. 3 apples plus 2 apples is not 5 apples squared. It's just 5 apples. So 3x plus 2x is just simply 5x. So if the terms are alike, you add their coefficients, but that term doesn't change. So when you're adding apples to apples, you get apples. When you add x's to x's, you get x's. When you add y's to y's, you get y's. But you can't add x terms with y terms. You can't add apples and oranges. So adding and subtracting variable terms in mathematics, those 2 terms has to have the same variable. The only thing that can be different is the leading number. The coefficient can be different. If there is no coefficient written, it's understood 1. So, can I add 3x plus 2y? No, I cannot. And I can't tell you how many times I've seen students do this. 3x plus 2y is 5xy. That is wrong. You cannot add those together. That would be like adding 3 apples plus 2 oranges. So no, you cannot add 2 unlike terms together. All right, hold that thought and let me change gears. I'll come back to that in just a minute. Now, let's talk about multiplying for just a second. Multiplying in mathematics has what's called a commutative property. The word commutative property means you can swap the order, but you still get the same answer. For instance, if you add 7 plus 3, or you add 3 plus 7, you get the same answer. That's a commutative property. So addition has a commutative property. Subtraction does not. If I say 7 minus 3, and then I do 3 minus 7, that's not the same problem. That's two different answers. So subtraction is not commutative. Multiplication, however, is commutative. If I ask you to multiply this string of numbers together here, and this string of numbers together here, the order in which you do them doesn't matter because of the commutative property. Now, keep in mind, let me go back. Can we add 2 plus 7x? No, we cannot. In adding, they have to be like terms. So the question now is, can we multiply them? And the answer to that is yes. And here is why. This is 2 times 7x. But remember, this symbol right here, there's no symbol in between this 7 and x. So this is really 2 times 7 times x. So you're really, though it looks like we're only multiplying two things together, you're really multiplying 3. But you can't multiply all 3 of these. But since multiplication is commutative, you can multiply these two together. So 2 times the 7 is 14, but you can't do anything with the x. So let's do that again. So can I multiply 5 times 4x? Yes, I can. That is 20x. But can I add 5 plus 4x? No, I cannot, because they're unlike terms. Now again, here you're really only multiplying the 5 times the 4 times the x. You're just multiplying those two things together. All right. Now, ignore these arrows right now. But let's suppose I have this. So just for a second, ignore this. Now this dot doesn't have to be here. 5 parentheses 3 plus 2x. Now I've got 5 times, not one term, this is two terms. In mathematics, plus signs and minus signs separate your terms. Multiplication is like glue. It holds the term together. So this is one term times, this is two terms. So you're multiplying this one times both of these. Anytime in mathematics you're multiplying one term times 2 or more, we give that a special name in mathematics called the distributive property. So I'm going to multiply this one term times 2 of these by simply multiplying this 5 times the 3 and then plus 5 times the 2x. Can I multiply 5 times 2x? Yes, I can. Now you say, Mr. Ryan, I thought in orders of operations you do what's in the parentheses first. We typically do. But in this 3 plus 2x, you can't add these two terms together. So if I could add those together, I would, but they don't add together. But I can still multiply this 5 times both of these terms. When I do that, 5 times the 3 would give me 15, plus 5 times the 2x is 10x. Now, I could have written this 10x plus 15. That's the same answer as well. But you cannot add these two together because this doesn't have an x with it. That is what's called the distributive property. Okay, so let's back up now and do some problems in this section together. All right. Section 1.4, Algebra Expressions. Algebra expressions are numbers and letters and the numbers and variables and powers that you're adding, subtracting, multiplying, dividing together. All right, so let's look at this very first one. So we're going to back up now and do some that we've already done. So I want to simplify these if I can. 5x plus 4x. Can I add those together? Yes, I can. They're like terms. I get 9x. Negative 3x minus 8x. Are they like terms? Yes, they are. So I can add and subtract them together. Now, here we are again, already using the same stuff that we used in the last section. If you lose 3 and then you lose 8 more after that, what have you done? You've lost 11. Remember the rule says if the signs are the same in adding and subtracting, you add the two numbers but you keep the sign. So that would be negative 11x. All right, this next one, negative 7x plus x. Are these like terms? Yes, they are. Remember, if there is no coefficient in front of this letter, it is understood 1. So this is negative 7x plus 1x, which is negative 6x. This next one, this is one sometimes students mess up on, x plus x. X plus x is just simply 1x plus 1x, which is 2x. If you're not real careful there, it'll be tempting to say x squared, or just x. If you have an apple plus an apple, you have 2 apples. If you have an x plus another x, you have 2 of the x's. Right here, minus 8x minus 1x. Yes, they're like terms. If you lose 8 and then you lose 1 more, you have lost 9 x's. All right, this next one, negative 10x plus 11. I cannot add these together. They are unlike terms. All right, now, let's look at this. A string of terms. Negative 3 plus 11x minus 6 minus 6x plus 14. Notice in every one of these, number term, number term, number term. But this is a variable term and this is a variable term. So I have 5 terms here, 2 variable terms, 3 number terms. A number term, another word for that is called constants. So we have 2 variable terms and 3 constants. Notice these 2 variable terms are like terms. They're both x's. So I can combine these. So what I'm going to do is the way I like to do it, is I like to underline the like terms. So I'm going to underline the x's once, and I'm going to underline the constants twice. Also notice when I underline them, I underline the sign with it. All right, so let's do these 2 first. If you win 11x, but you lose 6, you are still up 5x. Now the numbers. If you lose 3, you're down 3. You lose 6 more. That means you're down 9. But if you're down 9 and then you win 14, you are up by 5. So this would be 5x plus 5. Or you could write it 5 plus 5x. All right, now let's throw in some multiplying. 8 times 5x. Notice I said times. 8 times 5x. Can I multiply these together? Yes, I can. 8 times 5x is simply 40x. Now, 8 times 5 plus x. Now I have one